Hi, welcome to my video on graphing quadratic inequalities, part 4. In this video, we've done equations when they're in vertex form. We've done the equations when they're in standard form. Now I'm going to look at graphing equations which are in the factored form. So graph y is greater than or equal to x minus 3 times x plus 1. And notice we have x minus 3, so x minus 3, if we let it equal to 0, or we let x plus 1 equal 0, so x is 3, or x is negative 1. That's the x-intercepts of this expression right here. So the x-intercepts are 3, 0, and negative 1, 0. So the x-intercept is 3, so 3 is right there, 3, 0. And the x-intercept is negative 1, 0. So how do I graph? I need to find the vertex. So in previous videos, we took the x-intercepts and we added them together and divided by 2. So 2 over 2 gives us 1. So in the middle, that the x, this is the x coordinate of the vertex, is at 1. So the vertex got a x coordinate of 1. So it's the x, because the x-intercept is 3 and a negative 1, in the middle between 3 and negative 1 is the 1. So somewhere on, up, or down here lies the vertex of this parabola. And notice, if we could take this and multiply by FOIL and work it out and get it in standard form, but I just wanted to work on this form to show you the difference. So we take the 1 and we plug it back into the equation. So plugging it back in gives us negative 2 and 2. So the y coordinate is negative 4. So when we got the average of the intercepts, which is 1, plugging it back into the equation, or the inequality, or part of, if you pretend that's an equal sign, will give you the y value of your vertex. So this vertex is 1, negative 4. X is 1, y is negative 4, is right here. This is the vertex. The x-intercepts are 3 and negative 1. So now we can, if we want, we have all this information. We don't need any more information to graph it. We don't need, because we have the x-intercepts and the vertex, then we can draw our parabola. We don't need the y-intercept. But if you want to get the y-intercept, just to verify, the y-intercept is when you let x equal 0. So you go 0 minus 3, 0 plus 1, and you get negative 3 and 1. When you multiply, you get, so the y-intercept, x is 0, y is negative 3. So that would be right there. But, again, we didn't need to. So let's draw greater than equal to. Equal to means it's a solid boundary line. The parabola is solid. You shade it in. There's the boundary line, which is solid. Now we got to decide if we're going to shade down here or up here. Greater than, well, greater than is above, so we'll shade up here, coming off the parabola. So all the points that's in here satisfy this inequality. And again, to check, take the point, as I always can, if I can, take the point 0, 0 and sub in. Reason 0, 0, because when y is 0 and x is 0, they're easy to manipulate the numbers. Let's see, negative 3, 1, 0 is greater than or equal to negative 3. That's true. So this point is in the shading area, shading region. There it is. So that's using the vertex form. Again, it's just one of the other forms of parabola. Okay. Okay. And let's do another one. Again, we have the factored form. Y is less than the negative of x plus 4 times x plus 2. We want to graph this one. So, again, x plus 4 equals 0. X plus 2 equals 0. So x is negative 4 or x is negative 2. So that's the x-intercepts. And they're negative 4, 0, because x-intercepts, we have a negative 2, 0. X-intercepts lie on the x-axis. So we have a negative 4, 1, 2, negative 4, 0. Negative 2, 0 are the x-intercepts. And we notice that this parabola is opening downward because it's a negative. That means that the vertex must be up here somewhere. So right in the middle of this, if I do this, there's the axis of symmetry right straight down to the middle. And halfway between the negative 4 and the negative 2 is x equals negative 3. And that's the axis of symmetry. So the vertex must be up here somewhere and is going down through the x-intercepts. It can't be down here going up this way because it's negatives. It has to be up here coming down. So, and again, if you add up the x-intercepts and divide by 2, you'll see that you'll get the negative 3. So the x-coordinate of the vertex is negative 3. So you take negative 3 and plug it back into the equation and find out what the y value is. And that gives me a 1. That gives me negative 1. So that's 1 when we multiply. Negative 1 times negative 1 is 1. So the vertex is 3, negative 3, 1. So the vertex is x is negative 3, y is 1. Note the vertex is up above these intercepts because it has to come down. And again, we don't need the y-intercept, we just need these points. And it's no equal sign, so the boundary line is broken. Comes down like this. So here it is. Broken. And less than is below, so it's less than is down. So the shading is like this. And again, the point 0, 0. So if I try 0, 0 just to verify, 0, 0, this point is not in this shading. So let's try 0, 0 is less than the negative of 0 plus 4, 0 plus 2, 0 is less than the negative of 4, 2, 0 is less than negative 8, and that's false, or we could say no, that's false. So its shading is not outside here, shading is in here. And think, again, just a reminder, think about this is a border, a fence, and you're either on this side of the fence or you're on this side of the fence. So less than is this side of the fence, all points that lie here. And again, the parabola can keep going down and down and down as long as you want. And the further it goes down, then the shading is like this. So any point that's in here, in this shading, fits this inequality. Okay, let's continue. And I made up a different equation. Now we got a choice. We want to simplify the right side. So we have a multiplication, and a subtraction. So we'll multiply. X times x is x squared. X times negative 2, negative 2x. Negative 2 times x is negative 2x. Negative 2 times negative 3 is a plus 6 minus 2. Y is less than equal to. I have to add up the like terms. X squared minus negative x, negative 2x, negative 2x, negative 4. And 6 minus 2 is 4. And we could leave it like that if we want and work out the vertex. But I notice I could do, I'm just going to go down here. that less than equal to, that this is factorable, and in that it's, I just said x and x. Factors of 4 to give me a 4 was 2 and 2. And because the product is positive 4 and the sum is negative, it's a negative and a negative. So y is less than or equal to x minus 2 squared. Just happen to notice that this is factored as x minus 2 squared. If that be the case, then it's easy. If you notice that the vertex, when x is 2, which is the opposite of this, y is 0. Again, there's a 0 on the end. So when x is 2, y becomes 0. So the vertex is 2, 0. X is 2, y is 0. And if you plug x equals 0 into this equation, you get y, and you get 0 minus 2 squared. And you can have an equal sign if you want. So that's negative 2 being squared 4. Again, notice that the parabola is positive, so it's opening up. And so the vertex, the y-intercept is 0, 4. X is 0, y is 4 right there. And notice that if you're got, I just noticed that if vertex is here, so if you go 2 units to the left, you get a 4. So if you go 2 units to the right, you should also get a 4 because the parabola is symmetrical. And this is less than equal to, so equal to means the boundary line is solid, not broken. So there it is. Okay, and less than, as I know it, less than is down. So I got to shade down, so I can't go here. I have to go down. So this is the, all these points out here make this any, so any point. So again, we take 0, 0 and plug it into this inequality or into the beginning one. If we take 0, 0 and sub it into the initial one, 0 less than or equal to. Why am I subbing it into the initial one? I could have made a mistake coming up with this equation. So if I did, taking this point and subbing it in here would probably give me more justification for why this is shaded correctly. So 0 times that bracket is a 0, and that's 0, negative 3, so it's a negative 2 times 3 is 6, minus 2, 0 is less than 4, 0, yes. So this point, 0, 0, that's true, so we're shaded okay. Now another way I could have done this is I could have looked at taking this equation and said x equals negative b over 2a. A is 1, b is negative 4, c is 4, a is 1. So I had the negative of a negative 4 over 2 times a is 1. So that's 4 over 2, which is 2. So x is 2, perfect. And now I sub that in, I sub 2 in the equation, I'll pick up the y coordinate of the vertex. And again, equal sign or inequality makes no difference. That's a 4 minus 8 plus 4. 4 right there. 2 squared is 4. Negative 4 plus 4 is 0. So again, the vertex is 2, 0. So I could have got the vertex, if I left it like that, I could have got the vertex by doing x equals negative b over 2a, or if I could have done it this way, either or. And if I plug 0 in like I did here, I would come up with 0, 4. So just, if you did this, perfect, and do your graph, but you have to do x equals 0 to get the y-intercept because you want to know some other point other than its vertex where it's going. Remember, it could go down from this vertex. It could go up. So getting the y-intercept, which is 0, 4, is another point that tells you that how to draw it, up or down. Again, it's going because there's a plus. You can't tell here because there's too many expressions. But when you simplify it like this, because that's a positive, then we know it's going to go up. So picking up the y-intercept just gives you the boundaries. And that brings us to the end of this video. Again, different forms and shading in the inequality. And if you like my video, click the like button, subscribe button, and notification bell. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.